Hey everyone, good evening, guys. Awesome. So I hope everyone have joined so far. We can start. I think we have covered the conceptual part of all the pre-processing and other things, missing values, outliers, the encoding and scaling. Everything is done so by yesterday itself. We need to implement the coding. We need to see how exactly what are the functions, what's going to be the coding pattern in order to implement all those concepts, right? Perfect. So for today's agenda, we will cover whatever we discussed yesterday, we'll implement the coding for that. Whatever we did yesterday, we'll implement the coding for that. Okay? Yes, we covered encoding as well yesterday, label encoding and one hot encoding both. We discussed both the methods yesterday itself. Today we'll be doing the coding part of what everything we did yesterday. Okay? Okay. Before we start today's session, let me know if anyone have any questions. Anything, any questions before we start? No questions, we can start then. Usage of one hot encoding. The encoding methods are basically used to convert a text data, that is categorical text data, to numeric. That's what encoding is meant for. That's why we do encoding. And why it is important, because all the mathematical algorithms, all the algorithms, machine learning and everything what we will be covering in further sessions, they work on the core mathematics, and text can't be implemented to those equations. That's why we need to convert everything to numeric. That's the usage of encoding, right? Easy. Awesome. Let's proceed then. So we simply read our file, and this is how our data looks like. Then isNull.sum function will simply tell the total number of missing values in every column. This cell number 166 df.isNull.sum, it is telling us the total number of missing values in every column. Okay. Easy. So we can see there are two columns where we have missing values. We can see there are two columns where we have some missing data. That is the state percentile 15 and average score 15, right? So we have these two columns with some missing information, right? Awesome. In order to get the percentage of data missing, we can simply calculate isNull.mean. Into 100, we can also avoid it. I'll explain what is into 100. So if we do this and save it to some variable SR, this is how data looks like, right? So 0.017 means this is actually 1%. This is also 1%, 1.7%. So in order to get in percentage, we can simply multiply it by 100. We'll get it in percentage. Right. So this is the amount of data missing in the percentage of data missing in every column. Easy? Perfect. Then now this code will give us the data that has some missing values. Series where series is not equals to 0. So we have two columns that have some missing value. State percentile 15 and average score 15. These are some statistical columns. So let's see how we will treat the missing values here. Okay. Now if we just extract the index, it will return the column names. Right? So these are the columns where we have the missing values. Cell number 171 and 172. Understood everyone? 171. We are trying to extract the series where series is not equals to 0. So it will only return those values where those records where value is not equals to 0. And we are getting two, that is state percentile 15 and average score 15. We have 1.7 and 1.7 means they are not 0, means they have some missing values. And 1.7 is the percentage of data missing. Okay. Yes, SR greater than 0 means it should not be equals to 0. It should be greater than 0. So it will only give the values that are greater than 0. That is 1.7, 1.72, right? Yes, yes, yeah, okay. Now remember there was a rule that if any column has more than 30% data missing, we need to drop that column. So this will give the list of all the column names where we have more than 30% data missing. Right now in our data, there is nothing. There is no such column where more than 30% of data is missing. So that's why it's returning a empty list. But in case there is some column that has more than 30% data missing, this code will return that column name, right? This code will return that column name. Now, how this code is working? We are only extracting the series, this percentage of missing values, where the value is greater than 30. Dot index will give the column name and converting it to the list. So it will simply return the list of all the columns where we have more than 30%, right? What define greater than 30? A percent but no value? Sorry, I didn't get your question. Greater than 30 means more than 30%. If any column has more than 30% data missing, this will extract that. Yes? Thirty could be value. You mean value means like what we understand in that case? If we say 30 is a value, so what we understand, like what exactly is this number? SR is a variable. Okay, data should be greater than 30, but if we see here, we are applying it on the SR variable, right? And SR variable is what we have created it, and this is what SR is returning. And SR is actually having the percentage of data missing. So when we do greater than 30, it is actually the percentage only. Right? Abhishek, how did we get to know it's 30% or 30 values? By this. While we created SR, we simply did df.isnl.mean. So there is a mean. Mean will give the average value and then we multiplied it by 100. So it is actually the percent now. Got it? Awesome. So now this code will simply return the name of columns that is having more than 30% data missing, cell number 173. But in our case, in this data, there is nothing that is more than any column that has more than 30% data missing. So there is no such column for us. Now, this is actually just creating a copy of original data because we don't want to lose anything in case we made some step, if in case we made something wrong, we can easily roll back. So it's always better to create a, copy of the data before we make any change. 71 and 172. And 170, yeah, 171 and 172 are the similar things. In 172, we are actually extracting the index also only. So it will only give me the column names. It's not giving the value. Okay, so right now in 174, we are trying to create a copy of the original data so that in case, like, if we make any mistake, if we made any mistake, we can easily roll back to the original state of the data. So that's why we create a copy of it and then we will be working on the copy. Now this code will simply remove if there is any column that has more than 30% data missing, right? This code will simply remove cell number 175. It will simply drop the column if that column has more than 30% data missing. So what exactly is happening here? df1.drop list where SR is greater than 30 dot index and access equals to 1. Yes, because we see this code, the selected code is exactly this, right? Yes, that's exactly this code. And what it is returning? This part is exactly this. And this returns the column that have more than 30% of missing values. So we are telling drop those columns if they have more than 30% data missing, right? Understood? Cell 175, what this code will do? Yes, access equals to 1 to drop from the columns, correct. Easy? Yes, access 0 for rows, exactly. Yes guys, clear till here everyone? Yes, which part? Can you please let me know which part should I repeat? Yes. So here what we are trying to do, we are simply trying to drop the data that has more than 30% data missing. So this selected code will simply return the column names that have more than 30% data missing and drop function will simply drop those columns. 173 is actually the same thing. Series is having the percentage of missing values. So if the percentage is greater than 30, extract the value, the index, that is the column name. So it will simply return the name of columns that have more than 30% data missing. Okay. Yes, SR is something what we have created. Awesome. Good till here, everyone. All good till cell number 175. Great. Okay, now the quicker and the shorter way. Now this is actually not a code line, but this is also something we can use. We are simply iterating and replacing every missing value in every column with the mean itself. Yes, simple loop and replace with the mean. That's a quick way if we have a lot of data. If we have a lot of data, we can use this code. But again, this is not recommended. Sometimes we do it, but like not, this is actually always good to go solution. So this could be a possible way to deal with the missing values. Just loop all the columns and fill. See, fill any function will fill only at the place where the data is missing. And what we are filling? The mean of that specific column. Right? Easy. This cell, I'm not going to execute it because this is just for information. This way also we can fill the missing values. Let me turn it back to the raw code, raw cell. Perfect. Now let's actually try to see what's going to be, what's we are going to use in order to replace. Okay, first of all, state percentile 15. Let's see the data distribution. In one of the practical projects, here is an object check for the missing values and the outlets within the horsepower column and remove them. So we need to remove the null rows, right? Yes. Yes, in that case, we need to remove the null rows. There is a drop NA function in that case. We have a drop NA function, and inside drop NA, we can specify the subset. Right? Now, this one is not the grouped mean. This one is not the grouped mean. This is simply replacing it with the mean. There is no grouped mean right here. It's only replacing with the mean. Okay. Mean of the specific column. If like we are iterating the column, if that specific column has some missing value, it will replace with the mean of that column. Okay. We'll do the grouped mean also. Like we will cover the grouped mean, and I see that is there in some other cell. Grouped mean is when we group the data with some category. Right now we are not grouping it with some category. We are simply replacing it with the mean. Okay, perfect. Now this way we can check the data distribution. KD stands for kernel density estimation. That will tell us the data distribution. This curve we can observe to see whether the data is skewed or not. Okay. Now, does it look skewed, guys? No, actually, this is not skewed. This is not skewed. This kind of data is called multimodal data, but like if it's not skewed, we can use the mean. That is not skewed. Actually, skewed is when the data looks like this, right? That's what we call as a skew. When the data is like this is what skewed is, right? Or the data is like this. That's what the skewed is. But this is actually not skewed. This is called multimodal data. Multimodal means there are multiple these kind of things. There are multiple such bells. So that's called multimodal data. In that case, we can use mean, right? We can use mean. KD stands for kernel density estimation. Kernel density estimation, right? Estimation. KD stands for kernel density estimation. Okay, now this is actually the way we calculate the data distribution. Right now, this is not skewed and not even normally distributed, right? This is called multimodal data. It's not even skewed, not even normally distributed. In such cases, we can go with the mean, right? In such cases, we can go with the mean. Right now, we check the data distribution using kernel density estimation KD plot. This tells the data distribution. if we observe the data distribution of the specific column, it's not standard, it's not actually normally distributed, it's not even skewed. This type of distribution is called multimodal distribution. And in this case, we can simply use the mean, right? Let me explain again what's happening here. We are trying to plot kernel density estimation on a given state percentile 15 column. We observe the data distribution, KD plot, kernel density estimation. This KD plot is used to check the data distribution. And right now, if you observe the distribution, it's not even normally distributed, it's not even skewed. This type of distribution is called multimodal, and in such cases, we can go with the mean. Clear? Easy? Okay, awesome. Now, in order to replace it with the mean, we are simply calculating the mean, and we are simply doing fill NA state percentile 15 dot mean. So fill NA function is the function that will replace, that will fill at the place of missing values. Fill NA, the name itself is actually trying to explain what it will do. It will fill at NAs. NA means missing values. It will only fill at the places where the data is not there. And what needs to be filled, that's what we specify inside its attribute. So this is what we are filling, right? This is what we are filling. And what is this? Anyone can say what exactly this code will return, guys? Yes, mean of that column. We cannot use median because median is something we use in case of skewness only. If the data is skewed, then only we use the median. Yes, mean of the column. So when I'll execute this code, it will replace all the missing values of state percentile 50. Okay, now, right now, see, this is only returning the information. This is only returning the information. The original data will be impacted. It will actually save when we will execute this line of code, right? The original data will be, original data will be changed when we execute this line of code. Means we are actually saving what it returns. This is actually returning the fed information, and we need to save it to state percentile 15 column. Then the actual df1 will be treated. Okay. Yes, 178 means replacing missing values with mean. Yes, guys. Clear? Right now we are not, this will not save the change in df1. This code will save the change in df1. And like this hist is also similar to KD. This will also help us to check the data distribution. So either we use histogram or KD, that's the same. Okay. Yes, we can also use in place. Either we use the histogram or we can use the KD, both will work, but this also tells the same thing what KD does. So that is all actually the same way. We can use either histogram to check the data distribution, or we can use the KD in order to check the data distribution. So both are actually telling us the same thing. Let me place the cell above because it should be there. Yeah. So this is the KD plot, this is the histogram plot. We can use any of them to check the data distribution. Overall, we have decided we should be using mean here. Now, this is actually returning the data replaced with the mean, replaced all the missing values with the mean, and this will actually save it in original data frame. Clear? So when I'll execute this, now this specific column has been treated. And if we again check the missing values, the state percentile 15 is treated now. There are no missing values in this column. Easy? given check for the missing values and the outliers within the horsepower, and we need to remove the null values. Yes, well, the drop NA is the function and subset is drop NA. Inside the drop NA function, we have an attribute subset where we can specify to what column we need to drop. And it's replaced with the graph becomes skewed. No, it will not become skewed. Let me show you after the replacing. This is average score 15. This is another column, guys. This is average score 15 that is still having the missing values. Right? Okay, now we treated the state percentile 15, but now still one column is having missing values, that is average score 15. So if we check the data distribution, this is skewed, right? This is skewed. Yes. So in that case, what should be the imputation? What should be the imputation if the data is skewed? Median. So I'll simply replace it with the median. And that's it. There isn't. Okay, let me show you how to do the grouped mean method. Yes, we will use median in any type of skewed. EF1. Grouped mean is not here anywhere, right? Standard scalar, this is PCA. Okay, no problem. Let's see the grouped mean method, guys. df1 as everything is treated. Everything is treated right now. So in df1, I will again create the copy of df.copy. df1. There will not be a function like grouped mean method should not. I can try it, but if I remember, I haven't created a function with the name grouped mean. No. Grouped mean is here where we have created the group by. Okay, let's see, guys. So now I'm again creating, okay, so this way we have used the central tendency imputation and we have treated all the missing values. Now let's see the grouped mean method and also the backward fill and forward fill. So df1 dot is null dot mean. This function returns the average of missing values. Now this is our original data. We again have the missing values and df1, right? Now what is the column through which we can group our data? If we are going with the grouped mean method, what column we can use for grouping? Anyone? School type. We can group with the school type, right? We can group with the school type. Okay, now let me create a function. Def, I will name that function fill missing. And I will simply take the parameter calls. Okay. And we are going to give two values inside this fill missing function. That one will be the school rating, other column will be the column in which we need to treat the missing values. Okay. So let's say I am saying category will be the first parameter and the column in which we need to treat the missing value. I will simply mention it, treat missing will be the second parameter. Okay. We are just creating a function that will take a parameter. We are giving the category to group as the first value inside this parameter, and the second value is the column in which we need to treat the missing value. Okay. Make sense till here? Awesome. Now, if PD dot is null, treat missing. If this value is missing, okay, if it is missing, what we should do? We should return df1, where df1 dot school type equal category, right? And let's say we want to use the column. First, let's say we are creating it for state percentile 60 dot mean. So in order to understand this, let me just extract this line of code and let me explain it outside the function. Okay, so let's say what is the categories in school type dot unique. We have public. Okay, let's say we are giving public here. Okay, now tell me, what is the 60, anyone? In this 191, what is the 60.97? Mean of? Guys, public is a category. We cannot calculate mean of public. It is the mean of state percentile 15 only where the school is public, right? It is the mean of state percentile 15 only where the type is public. This is the mean of state percentile 15 only when the type is public, right? That's what it's returning. Understood? Public is a category in school type. Public is a category in school type. No problem. This code right now, cell number 192 df1, where df1 dot school type equals to public. So if I just remove this will only give me the data where school type is public. See, school type is only public, all the fields. So this code is only returning me the data in which school type is public. I'll share the file, no worries, I will give you the file. It is only returning the data where the school type is public. Now here, if I only want to extract state percentile 50, so I'll simply mention the column, and it is only giving me the state percentile 15 where the school is public. Yes. And when we do dot mean here, it will give the average of state percentile 15 where school is public. Yes. Okay. Now let's try to make this function more specific. This is state percentile and this is school type. Okay. Now school type equals to school type state percentile dot mean. Now this function will take state percentile 15 value and the school type value for a given record. So okay, let me finish this function and then I'll explain so that it will be more clear. Else return state percentile 15. Okay, now see what this function is doing. What this function is doing. Oh, my bad. 15. Okay, see, now let's try to understand what this function is doing. Suppose this is the data. Okay. Yes. So it will be applied on every column, every row, one by one. This function will be applied to every row one by one. Let's say this is school type, and this is state percentile 15. Suppose we have these two columns. Now this data will be fed into calls function. This data will be fed to calls variable in this fill missing function. We will feed this data. The first value will be school type, the second value will be state percentile 15. Now suppose if this is missing, suppose if the data is missing here and school type is public here, right? The school type is missing here, sorry, the state percentile 15 is missing and school type is public here. Makes sense? That could be a possibility. Let's say this is also missing and here it is public magnet. Public magnet, right? Possible. And rest we have the data. We have the data. We have the data here. Assume we have two values missing. Now we will give this thing to this function. The calls will, the first value will be the school type and the second value will be the state percentile 15. Clear? Yes? One by one, guys. Let me finish the topic, then we will see, we'll talk about the questions. So is it clear? We will give this value to the calls. First value will be state school type, so the calls 0 will be school type, and the second value, sorry, this should be 1. This should be 1. The second value will be state percentile 15, right? This will be state percentile 15. Clear? I'll show you that how we are going to loop. Let's try to understand the logic inside the function first. Let's go one by one, guys. Let me finish, then we will take the questions. Let me finish this logic first. So is it clear about like till these two lines? Is it clear till these two lines? Everyone, what's happening? Yes. Okay. Awesome. Right now it is checking if it's missing state percentile 15. If state percentile 15 is missing, if this value is missing, it will only return the mean of state percentile 15 where the school type is public, right? It will return the average of state percentile 15 for only those records where school type is public, and that was the grouped mean. If state percentile 15 is missing, it will return the average of state percentile 15 where the school type was public only. Yes? And similarly, when this value will be applied here, it will see state percentile is missing. It will only return the average of state percentile 15 where the school type is public magnet. I wrote school type equals to school type because here we are actually accessing what is exact category of the school type. Here is the category where we have extracted the school type, right? So if it was public, that will get stored in the school type itself. If it is public magnet, it will get stored in school type itself. Yes. We are giving this information in the parameters. Again, let me explain this entire logic again, guys. This is the data. We will give this pair of information one by one to this function. Okay. We will give this pair of information one by one to the function. Okay. Is it clear? We will give the pair of this information one by one to the calls value. Yes, this thing is clear, everyone? Cool. Now to extract the value of school type, we are using school type variable, and to extract what is there in state percentile 15, we are using state percentile 15 variable, right? So first we give this pair, the public will get stored in school type and NaN will get stored in state percentile 15, right? Then we will give another pair, whatever will be the value at here will be stored in school type, sorry, whatever value will be here, that will get stored to school type. Whatever value will be there, that will get stored to state percentile 15, right? And again, we will move to the third pair and so on. We'll apply it for all the rows. Clear, everyone? Perfect. Perfect. Now it will check if the state percentile is missing or not. It will check if state percentile 15 is missing or not. Okay, this is the condition. If this value is missing, if yes, it is missing, it is returning the average of state percentile 15 where the school type is whatever we have received here, right? If it was public, this variable will store public. So it will simply give the average of state percentile 15 for the public only, right? Make sense? Otherwise, it will simply return whatever is this value. Okay? Otherwise, it will simply return the state percentile 15. So whatever this function will return at the end is the treated missing value treated variable, missing value treated column of state percentile 15. Okay? Is it clear? Is this function, this logic is clear? What if the school type value is missing? In that case, we will not be using grouped mean method. So whenever we use grouped mean method, make sure the category through which we are grouping should not have any missing values. If there is, we will deal with that missing values before we do the grouped mean. Okay, now the logic makes sense. Now let's see how we are going to apply it. Now, in order to apply, I will simply do df1 first school type, then state percentile 15 dot apply the function name fill missing, simple function name, and give access equals to 1 because it should take the values from column and iterate the rows. What's wrong? Trait missing is not available. I might have not executed this. Yeah. Okay, cool. Now see, this is actually returning the state percentile 15 after treating the missing values using the grouped mean method, right? It is returning the state percentile 15 after replacing the missing values with grouped mean method. Easy? And in order to save the change, we just need to save it this way. This will save, right? This will save the change. Okay, now is it clear that yes, how we actually iterated for all the rows and we picked the information from columns and gave to the fill missing function and it will treat the missing values? Yes? Got the grouped mean method? Let me know if anyone have any question, any doubt. If access 0 will not work in this case, if we give access 0, right now what's happening? Right now what's happening? It is taking the pair and iterating the rows, right? It is taking the pair of column and iterating the rows. If we make access equals to 0, it will take the pair of rows and iterate the column, right? Right now, it is picking the values from column and iterating the rows. But if we make it access equals to 0, it will pick the value from rows and iterate the column. And that's what we don't want, right? Correct? how will we pass? See, we are selecting the columns. Only these columns will be passed to calls to the parameter of this fill missing function. By default, it will use 0 and that will be the other case. If we don't specify, it will use 0. See how we are giving the values to calls. We have selected the data, school type and state percentile 15. These two values will be given to calls by itself. Like this thing will be done by the supply function itself, and the parameter of the fill missing function will be invoked with these two values. So this is actually how the calls is being invoked, right? School type and state percentile 15 are getting inside this calls variable. If I change these variables, that's what will get inside the calls. Okay. But the function is accepting only, it is passing it in a list. See, it is actually taking two values, calls 0 and calls 1. So both the values are given in the same variable. We can give, yes, a single variable can carry two values in tuple, list, and lots of such variables are available. Lots of such data types are available in which a single variable can access multiple values, right? And if we see the calls, we are we are accessing the two values in zeros, 0 and 1. Calls 0 is the school type and calls 1 is the state percentile 15. Yes. Yes. Any questions about this fill missing? No, not public. We haven't specified public anywhere. Whatever will be the school type, it will use that. Can we give n number of columns in calls? We whatever columns we select here, that's what will be feeded inside calls. Whatever columns we select here, these columns will be feeded in calls. Okay. Understood? Whatever columns we have selected in the data frame before we apply the fill missing, those columns will be given to calls. That is also a way we can use the fill. That is also possible. This is a method, so we can also use this method. It's not about the easy thing, guys. It's actually not about what is easy and what's not easy. It's about what's more accurate, right? So that is also a method. This is also a method. In there could be a lot of scenarios where group to mean makes more sense than using the mean. So we would go with the group to mean, right? df1 is just above. We have created df1 equals to df copy. Calls 0 is not public. Calls 0 is the information available in school type. It could be public, public magnet, whatever is the information, it will store that. And df1, did you include only, no, df1 have everything. Here we are only selecting school type and state percentile 15. df1 have everything, but when we apply the fill missing function, we are only applying it on two specific columns. One on which we need to fill the missing values, the other one, that category, what we are using to group. Right? Again, guys, remember, let me explain it again, and I hope all the questions will get resolved by then, because if we keep on answering the questions, it will take more time. Let me explain again. This is school type column. This is state percentile 15 column. Okay. We have different rows in it. We have different rows and so on. Let's say here it's missing. Here it's missing. And the school type is public here. The school type is public magnet here. Okay. Now first, the calls will take these two values. When we apply fill missing on school type and state percentile 15, the calls will take the first value here, right? It will check whether the state percentile, it will just extract whatever is available here, anything XYZ, whatever is available in here, and whatever is in this place will be stored to school type and state percentile 15. Is it clear? Can you show dataset is the exactly same dataset what we have been using earlier. It's the same dataset, guys. That's the same dataset what we have been using earlier, right? Wait. SSDF1. Okay. Calls is not a variable what we are defining. Calls is just a function parameter. So we don't need to define a function parameter, right? Calls is a function parameter and we don't need to define a function parameter. We know how we create a functions in Python, and while we create a parameter inside a function, we need to define or initialize that parameter before we use it as an argument. Yes. Calls is a variable that will take the information and that variable will be utilized inside the function body to refer that information. Yes, makes sense? Calls is just a variable that is that will take the information, feed it to this function, and this variable will be utilized to refer to that information, right? Okay. Now is it clear that we have this, we are selecting school type and state percentile 15. This is school type, this is state percentile 15. These are the values and the calls is going to get the pair of these values one by one, right? The calls is going to get the pair of these values one by one. Clear? Yes? Okay. So when I say it's going to get the pair, calls 0 will be having the XYZ and calls 1 will be having ABC for the first one. Now XYZ2 ABC2. For the second iteration, calls 0 will be having XYZ2 and calls 1 will be having ABC2, right? Yes? Clear? Okay. Now it will check if the second value, state percentile 15, it will check if this value is missing. For this specific record, we have state percentile 15 missing, right? Right? Then, then it is simply returning the average of state percentile 15 if the school type is public, because that's what it's storing in the school type variable. The public will get stored in school type and nan will get stored in state percentile 15, right? And this state percentile 15 is 9, so it will simply return the mean of state percentile 15 where school type is public. Make sense? Otherwise it will simply return the state percentile 15. Now got it, how this function is working and how this function is being applied to the entire data set and how it is implementing the grouped mean method. Everyone? Okay. Now two columns, with that mean in that case, if we need to fill two columns, no, we need to do one by one at a time. We need to do one by one at a time. Okay, guys, in order to understand it more, we have spent enough time on this concept. In order to understand it more better, I hope we got the idea, we got the foundation. Just try to read about .apply function in pandas, right? Just try to read, try to practice how does .apply function works in panda. Okay, we got the sense how this is working. In order to explore how to deal with multiple columns, how to deal with multiple categories, multiple continuous variables, whatever your curiosity is, try to explore this how apply works in pandas, and then you can do the further experiment. Okay, yes, makes sense everyone. We can proceed then. If this idea, like how exactly this grouped mean is working, if this is clear, we can proceed. Everyone? Awesome. If you are getting any error, I will share this code, this file again in the Google Drive. You can refer to this code. Okay. Perfect, guys. Perfect. Let's proceed then. Now, after this execution, it will simply replace the missing values. And if you check this code again, now state percentile 15 has no missing values, right? Easy? Easy? Everyone, easy? The grouped mean method? Awesome. Perfect. Now let's come to the outliers. Definitely, definitely. We can definitely explore, guys. Because apply, I just have shown you one application of a apply function, how we can use apply function. But apply has a lot more potential. So you can definitely go and explore, read more about the apply function in pandas, and then it will be even better about this logic. Okay. Perfect. Now, for the outliers, we can simply plot a box plot. Now, again, I am just using this hypothetical column size. What column we should be selecting, what column we should, in what column we should treat the, outliers. That is something we had already discussed yesterday. Right now, we just pick the size column for explanation. For example, how we are going to deal with the missing values in size. So we are simply doing the box plot, and we can see this whisker, anything above than this whisker is actually an outlier, right? Easy? That's what we discussed yesterday. The box plot gives the upper and lower range, that is Q3 plus 1.5 IQR, Q1 minus 1.5 IQR. If anything is below this and anything is above this specific value, that is an outlier, right? Perfect. Now, not very hard and fast, but roughly we can say anything above 1500 could be considered as an outlier. Yes, not very hard and fast, but roughly we can say anything above than 1500 could be considered as an outlier, right? Sure. We talked about how do we detect the outliers by IQR method. So these whiskers in a box plot, this value is actually Q3 plus 1.5 IQR, and this is Q1 minus 1.5 IQR. So anything above Q3 plus 1.5 IQR should be an outlier. And these dots, what we are getting, these are actually the outliers. And roughly we can pick this benchmark of 1500, right? So that's how we detect the outliers. And in order to remove the outliers, we are simply selecting the data where size is less than 1500, right? We simply need to filter the data where size is less than 1500, and it will only have the data that's not an outlier. What is Q3? Q3 is 75 percentile. We have to check for each column one by one. No, we had discussed this thing yesterday itself, that when do we need to treat the outliers. Not every column is required to be treated with the outliers. If we have a target variable, we need to deal with the outliers in target variable, or it depends on the initial hypothesis we make before we start the modeling, right? Like if we are selecting some column as our initial hypothesis, that's the most important factor in our model. So we need to deal with that. Otherwise, we don't need to check each and every column, right? Make sense? Q3 is 75 percentile, third quartile. Clear? It's positively skewed for this particular box plot. Yes, we can definitely say it's skewed. Okay, now let me explain the code one by one, guys. See, this line of code will simply remove the data that is greater than 1500, right? If we see, this is a simple filter that will remove if the size is greater than 1500, right? That's a simple filter, and it will remove all the rows where size is greater than 1500. So this way we will be able to remove the outliers. Yes? Less than 1500. So this is what we are actually including. This is not how we are excluding. This is how we are including. Less than means this is what we will consider. This is what we will keep, and everything apart from that we will drop. Right? But it states rem for remove. That is just a variable name. This means now this variable will hold the data after removing the outliers. We are storing the data, we are storing the result in data frame itself, guys. See, okay, if I only keep the data after this filtration, if I only select the data that is less than this, if I'm only selecting the data that is less than 1500, so this way this data will get dropped, right? Yes. Is it confusing? If we only select the data that is less than 1500, this way definitely whatever is greater than 1500 is being removed, right? Make sense? So this variable is actually storing the data after outliers are removed, right? df1 outlier removed, this variable is storing the data after we removed the outliers, right? Correct? Perfect. Now, what will happen if we create the box plot again on this data? Okay, now this is the box plot of the data after removing the outliers. Now tell me, are these values what we are getting again as outliers? Should we treat them or not? Anyone? We still are getting some values as an outlier. Should we treat them or not? We should not treat them. Why so? Why so? Because th- After removing the IQR, Q1, Q3 and Q2 values will get updated, right? After we removed the data, the original quartiles will get changed, right? And these are the outliers after we have removed the data. These are the outliers with respect to the data after outliers treatment. And the quartiles what we are using in this box plot are not the original quartiles, right? The quartiles what we are using in this box plot are not the original quartiles of the data. Make sense? Make sense? Why these are not actually the outliers? These are not the outliers, guys. These are not the outliers because the original quartiles value will get changed after we remove the outliers. The original Q1, Q2, Q3 will get updated after we remove the outliers, right? And this is what we are getting, the new quartiles on the new data we have. Understood why this is not an outlier, guys? This is not an outlier with respect to the original data. Easy? Awesome. So this way we can treat the outliers in any data. That's how we can treat with the outliers. Perfect. Now let's proceed next. What we have next? Okay. Now this is how we are actually checking the percentage of data dropped. So we have actually dropped 6% of data. We are removing the outliers. Then how it is affecting the original quartiles? Okay. So how do we calculate the quartile, guys? 25 percentile, 50 percentile and 75 percentile, right? Suppose you have 100 observations, right? You have 100 observations. So for these 100 observations, you have 25, 50 and 75 percentile values, right? After you have dropped 6 records, you left with 94 observations. So these quartile values for these 94 observations will be different. Perfect. Okay. Clear, everyone? Awesome. So now the cell number 207 is actually telling us the percentage of data we have dropped. So we have dropped 6% of data here. Okay. We have dropped 6% of data here. And that's not too huge. Okay. 15% is something what we go in worst case. So 6% is okay. Understood? Awesome. Now a quick tip, the histograms, the scatter plot and the KDs also gives us some idea about whether the outlier is present in our data or not. Okay, so these plots can also give some idea, some visual idea about whether the outliers are there or not. How much? It's like maximum again. There is no hard and fast rule. If I tell you honestly, there is no such hard and fast rule. In some cases, we often go to 30%, and in some cases we don't even want to lose more than 5%. But a standard or good to follow rule is extreme 15%. Now this completely depends on different data set to different data set, right? For example, if I pick a business use case where we have the sales, where we are actually targeting the sales. So in case of sales, the outliers are the prestige customers, right? If when we talk about the sales, what outliers we call in terms of sales, they are our prestige customers because they are making expensive purchases. Though they are outliers, but they are making expensive purchases. Means they are important for us. Right? Make sense? Yes. So we need to change those rules. We need to think in that way while dealing with the outliers. So definitely there are different, exceptions, but it's good to follow rule is 15%. Not only for outliers, missing values, everything we try to restrict ourselves in order to, make any impact, any change on the data. More than 15%, like we should not go more than 15%. Okay, make sense? Little confused why we are using DF and not DF1. DF1, we simply created a copy of the original DF so that we don't lose any information in case we make any step incorrect. Sure. Okay. I will tell you about what that shape and other things are. So before that, I just wanted to explain this. These plots also gives us little idea about the outliers. So even if the box plot is obviously the solution, apart from the box plot, the KD, the scatters, and the histograms can also give some idea about the outliers. Make sense? Right? Okay. Now what's happening in this case? We know when we do dot shape, when we do df dot shape, what it returns? Rows and columns, right? And when we'll do dot shape 0, it will only return rows, right? And when we do dot shape 1, it will only return columns. It will only return the number of columns we have. And dot shape 0 will only return the rows. Make sense? Make sense? Okay. So now understood what's happening here, dot shape 0, dot shape 0. Easy? Perfect. Yes, guys. Now let me know everything is clear with the missing values and outliers. Yes, guys. Everyone, everything is clear about the missing values and outliers. Awesome. Awesome. So these are some, visuals through which you are calculating the percentage of outliers. Yes, other percentage of data we have dropped. Perfect. Now these are some other visuals through which we can get some idea about whether the outlier is present or not. We can see there are some, some records that can be treated as outlier and also in the KD. I'm glad we are getting down the road. We are understanding the things. Brief, where to use different visualization functions. Okay, so if we need to display some trend, we can use line chart. If we use to compare some category with continuous, we can use bar chart. If we have multiple continuous variable, we can use scatter chart. Okay, scatter when we have two continuous variables, one category, one continuous, bar chart. Both the categories, in that case, what would be the scenario to plot two categories? Um, no, like in case of categories, we will be having something continuous like number, the count frequency of the category of the percentage of the category. In that case, if we want to calculate the percentage, we use the pie chart. But continuous, scatter, category continuous, bar chart, and if we have some trend or something, line chart. Okay. Histogram KD just to check the data distributions. Histogram KD just to check the data distributions. Sure. Again, guys, if we have two continuous variables x and y, both the axes are continuous, we go with the scatter plot, right? One is category, one is continuous. We can go with the bar plot. Clear? The trend line chart. Okay. I will share some code files. I will just remind me about this at the end of the session. I will simply go through with the codes or the notebooks that are available in the Google Drive to explore the different visualization techniques. So there are some notebooks available in which we pick the data set, we made the visualization in order to carry out some good insights. Basic dashboard kind of thing. So I have some codes like that. Just remind me at the end of the session. I'll just navigate you where to look for those files. Okay. Yes, guys. Just remind me all these things at the end of the session, ebooks, resources, and everything. I'll navigate everything. Okay. Now encoding categorical variables. So in order to encode a categorical variable, we need to create some categorical variable. So right now we are just creating a dummy variable, dummy data set, in which we have data frame with two columns, age and income. Okay, we have two columns, age and income. Which one is categorical here, guys? Which column is categorical here? Income. So we can simply encode it using this map function where every category can be encoded to some number, right? I mentioned some combinations to select. Sorry, combinations about the visualizations. If there are two continuous variables, we go with the scatter plot. Two continuous scatter, one category, one continuous bar chart, and if you want to plot some trend, line chart. I'll also give you, a reference code file to explore the different visualization techniques in Matplotlib. I'll upload the resources, guys. Just remind me everything at the end of the session. I'll upload everything in the drive. Okay. Perfect. This makes sense. Income.map low to 1, medium to 2, high to 3. The simple encoding method. Now this is something we can easily do if the number of categories are less. We can manually type low should be 1, medium should be 2, high should be 3. But this is something not every time we can do. Suppose we have more than 10 categories, then we cannot go with this map function. Right? This map makes sense, everyone. We simply converted low to 1, medium to 2, and high to 3, and that's what it's having in encoded. Easy? The cell number 214. Okay. The other way is label encoder and one hot encoder. So one hot, okay, we can skip the one hot thing because what one hot does can easily be done by the get dummies function. Still, I'll explain you how it works. Okay, now this is the data frame where we have the gender. Right? How to group? There is a cut function in order to categorize. That's called categorization. That's called categorization. In order to categorize some continuous variable, we have a function cut, pd.cut or pd.qcut, cutting based on the quartiles, right? Percentiles and quartiles. So we have cut function. We'll see cut function in regression problem. Cut function will be utilized in a regression case study. So we'll see then. Okay, now here we have the data frame where we have the age and gender, and let's suppose gender needs to be encoded. Okay, gender needs to be encoded here. Remember we discussed about label encoder and one hot encoder yesterday? Remember? Okay, now let's see how the label encoder will work. The programming pattern in order to implement the label encoder is we create an object of label encoder class that is an LE, and we execute le.fit transform function, and we specify the data that needs to be transformed, and it will simply do the transform. Okay, I haven't executed this cell. Yes. If we see, we have simply imported the label encoder and one hot encoder. We created an object of label encoder that is an LE, and we invoked le.fit transform. We specified the data what needs to be transformed. It will simply transform and save it into gender TF column, that is gender transformed. Okay. Easy? Easy? Okay. Now remember the other way of transformation. So that can easily be done by, this is the data frame. Okay. Now, if I do pd.getDummies, pd.getDummies, specify the data frame and specify the columns. We only want to do it for gender. So see, it will just create the two variables for gender female and the gender male, and it will do the one hot encoding, right? Easy? Yes. Label encoder will take alphabetically. F comes first, so F will be 0, M will be 1, just alphabetical order. Okay? And that's how the getDummies function work. That's how the getDummies function work. Easy? Line number 224. What's happening in line number 224? We simply said pd.getDummies, specified the data, specified the column in which we need to do the encoding. Gender was the column, male and female, so it created separate column for male and separate column for female, and it transformed the gender into binary. It's actually creating two variables, dummy variables, gender female and gender male, right? This is similar to one hot encoding. Yes, it is similar to one hot encoding. What one hot encoding does is being done by this getDummies function. Okay, what one hot encoding does is being done by the getDummies function. Yes, yes, yes. Okay, now the big question here is, when should we use label encoder? When should we use getDummies? Right? The major question is, when do we use getDummies, like this kind of different columns, or when do we use label encoder? The answer to this is, again, not a very hard and fast rule to follow, but this is something good to follow. When the category is ordinal, means there is some order in the category, like high, low, medium, small, large, or medium. If there is some order in the category, we go with the label encoder, right? And if the category is nominal, there is no order, we go with the one hot encoder or the getDummies function, right? If the category is ordinal, ordinal means category is carrying some order, like high, low, medium, small, medium, or small, large, extra large, whatever. Like if there is some order of the categories, we go with the label encoder. If there is no order, we go with the one hot encoder. Make sense? If the categories are in some order, if the categories categorical variable is ordinal, means the column is following some order. For example, the size of the clothing, small, medium, large, extra large, double XL, and so on, right? So that has some order. In that case, label encoder is something we go for. And if there is no order, for example, the category of a food, so category of food is not going to have any order. In that case, we will be using get dummies. Dummies function only work in binary. It will only give 0 and 1, right? Get dummies will only give 0 and 1. If there are 5 columns, it will create 5 different if there are 5 categories, it will create 5 different columns with zeros and 1. Okay? Exactly. If data can be ranked, means if there is some order, label encoder, otherwise one hot encoder or this get dummies. One hot and get dummies are actually same. Yes, guys. Understood? Easy, everyone? Clear about the encoding and everything? Anyone wants to answer where we use on one hot? Thanks, guys. Unordered data. Okay, now to do the same thing what getDummies what getDummies function work, in order to implement the same thing using one hot encoder, we actually have a long way to do it. We need to create an object, then fit transform, and then to array. And this will even return an array. We need to save it to a column first. So what get dummies will do in a single line of code, one hot encoder will take some multiple uh, instructions to do that thing. We need to create the object of one hot encoder first. We need to transform, convert it to array, and it will transform it as an array. And this array needs to be stored in a data frame. Correct? Ultimately, we will be getting the similar result as what get dummies does. Okay, understood everyone? Awesome, guys. So now we can take a break. After the break, we will do the scaling thing. We will implement the scaling part, and then we will just have a quick discussion about the steps involved in order to solve a machine learning problem. Some technical aspects as well. What are some technicalities we need to take care of while we solve the machine learning problem? And also we will get an overview what should be the roadmap in order to get the solution. Okay, sure, I'll unmute you. Okay. We no, we won't be able to cover PCA. We will be doing PCA tomorrow. And yes, we are good with the pace, guys. We are good with the pace. 15 minutes. Let me start the polls also. Yes, the polls are open, guys. Yes. PD dot categorical will simply convert the nature of a variable. It won't transform anything. It will simply consider that variable as a category. Okay, it will simply, like, as we understand something as a categorical variable, Python also have some sort of data types for the categorical and continuous. So when we do PD dot categorical to some function, it will change that nature to the categorical. It will not change anything in the data. Okay, like converting a data to string, converting a data to numeric, or that typecasting sort of thing. Sure, just a sec. Categorical is some sort of typecasting. No, not some of that group. It's simple typecasting kind of concept. It will simply do the typecasting. Excuse me. Sorry. Monica. Yes, Monica, you can speak.
Yeah, hi Abhilash.
Hi.
Yeah, actually, my question is, whatever the field, like whatever the domain, the first thing is data is important, right?
Right. Yes.
Yeah. So we know how to import data. And my question here is, before moving to the how many unique values in that, what is the shape of that data? I want you to explain which column is target or which column is independent, which is dependent, which is classical, which is categorical. Like that, I want you to explain that before moving to further. When we import the data, we need this.
Okay. So
Actually,
what
yeah.
exactly is categorical variable and what exactly is continuous variable is something I think we have discussed in the second class itself. We talked about the
Yeah, yeah, actually it's discussed, but what my question here is when we import the data, in
Mhm.
that data, I want you to explain this is the categorical, so this will come to categorical, this will come to like yeah, this is the target variable, this is the independent, these are the features.
The target variable and the dependent independent variable is actually not something we have started yet. So whenever
Yeah,
we'll
okay.
reach to the algorithm part and other things, we'll talk about that also.
Yeah, and I have one more concern, Abhilash. Actually, I want you to be like a coder in on spot. Like if you are going to explain these things like outliers or missing values, I want you to write the code on spot.
That
It's
will take
my concern only. Yeah.
that is something we can definitely do, but coding during the session is going to take a lot of time. If we have the codes already prepared and we can execute, we can understand the codes. That is something we can do quicker. But if we start writing everything, it's gonna take a lot of time.
Okay.
That's why we keep the things prepared.
Okay. Okay. It's just concern only.
Yeah,
Yeah. Thank you, Abhilash.
perfect. Okay, let's get back after the break, guys. Hey everyone, so we are all back now. Okay, so I see there are few messages. Answer data about the schools. No idea what we are processing, what's our intention even. There should be a broad picture, what our ultimate aim is, and that's how should work. Okay, basically, let me try to explain how actually we are proceeding. Right now, there is not a specific problem statement what we are trying to solve. We don't have the problem statement in hand yet, and like we have to reach to that level when we try to solve some problem statement. We have some intention, we have some objective, and we need to proceed with some certain steps in order to achieve that objective. We haven't reached that state yet. We are trying to understand the steps, the individual concepts, what is missing values, what is outliers, what is, why do we need to encode a categorical variable? How do we encode the categorical variable? We do not have the problem statement in our hand right now. First thing, we are trying to understand the unit steps, unit logics. What are the concepts we need to follow? What exactly is the missing values? When do we need to deal with the missing values? When do we need to deal with the outliers? These are the small unit concepts what we are discussing right now. So if I talk about the overall picture, that is something we don't have as of now. We will proceed to that part. We will proceed to a problem statement. We'll talk about the algorithm, and then we will discuss what is the problem statement, what is the data set, and what exactly is our aim. That makes sense? That makes sense, guys? Right now, whatever we have discussed so far, we are just discussing the unit concepts, right? And we talked about everything. If we started the missing values, if we started the outliers, if we started the encoding, we talked about what exactly is encoding, why it is necessary, and when we should implement the encoding, when we should implement it, when we should implement the missing values and everything, right? Make sense? Yes. Please, guys, let me know if I'm missing anything, if I skipped or I missed anything what we have discussed so far. Yes. So if we talk about the overall aim, if we talk about the overall objective, we haven't reached to that level yet. And even if we, like when we reach to that state, when we will be having a data set, a problem statement, and certain, certain methods to follow in order to achieve our objective, we need to understand those methods first. What are those individual methods, right? If we won't understand the methods, we won't be able to pick a problem statement and achieve, we won't be able to solve that. So we need to understand individual methods first, right? Yes. Does that make sense? Right? So right now we have discussed what is missing values, outliers, and all those things. Further in the case studies, we will see where we need to implement the missing values, outliers, and other things. Right? Please let me know if anyone have any other thoughts. Yes, guys, please let me know if there is any concern about this, like the way we are going ahead right now. Yes? No one? Okay. And if I remember, if I'm not wrong, guys, please correct me if I skipped the first, I think it was the second class when we started this Pandas basics file, right? It was, I think, the second class when we started this Pandas basics file. And the very first thing when we started this data set, where it is the missing values and the outliers. Let me navigate you to the code. Wait a second. Okay, here it is. At this point, we talked about this unique and value counts function, right? And before we discussed unique and value counts, we talked about these variables. What are the columns? Which one, like what is numeric, what is categorical, what is discrete? In this data set, we discussed about the natures, the continuous data, the categorical data, and the discrete data, if you remember. Yes, guys, have we discussed that when we were discussing these things? Yes? Please correct me if we skipped something or if we missed something. Have we discussed about the nature of variables, discrete, categorical, and continuous? At this point, I think it was second class. Yes? Perfect. Perfect. And apart from that, we also have the self-learning video section, the self-learning section at this point. Right now, we are at this lesson 3, data pre-processing. How many of us are covering these lesson 3? Yes, guys, how many of us have gone through with these videos? And how many of us haven't gone through with these videos? Completed? Not yet? Awesome. Guys, small, I would like to request a small request to everyone. If we are facing any difficulty, if we are actually, we are not able to understand, we are facing any challenges in understanding the concepts, please try to put small efforts, some efforts in going through these videos. These videos are there just to stay a little bit prepared about the live sessions what we are going to discuss, right? Because we understand we have learners from different background, from few people may have some technical background, few people cannot have some technical background. That's why these self-learning videos are there, to stay a little bit prepared about the live sessions what we are going to discuss, right? Yes, guys. So today, like there were few concerns about the things, the nature of the variable, and we should have a overall aim. So I just addressed, like right now we are not at that state where we have some problem statement in hand. We are trying to discuss the methods, unit methods, right? And that is actually important. Like if we won't understand the unit methods, we won't be able to solve the problem statement. Make sense? Let me know if there are any other concerns, anyone. If not, we can proceed, guys. Yes, guys, the codes, everything I've already shared. All these files, what like this pandas basics file that has the entire, pandas, like the 3 sessions, the content for the 3 sessions, second, third, and fourth. This file has the entire content for the 4 sessions, and we have already shared it. Like it was second day also. This entire file is already shared. Okay. Is there any easier way to remember the codes? Let me tell you the truth. We don't need to remember the codes. We don't need to learn the codes. Practice is required to get a right grip, to get the grip about the syntax. But honestly, we don't need to learn or remember the codes. It's like we are free to Google, we are free to refer the codes. All we need to know what needs to be referred, what needs to be searched on the Google, right? If we know the right approach, if we know the right, step, we can definitely refer the coding part from Google and from our other code files and everything. So right now, if you are more concerned about learning the code, don't worry about it. Meanwhile, like as you will do the practice, as you will try to solve the problem statement, you'll definitely gain the grip over coding syntaxes and other things. We don't need to remember and learn the patterns. Okay, right? Simply learn assessment is enough for practice. You mean to say what's there in here? That's enough, guys. Trust me, if we cover all these things, it's actually enough. And even if you require more, I have shared you one more Google Drive link. Yes, I have shared you this Google Drive link. So as we proceed, as we will cover more topics, I'll start addressing which folder you need to refer to explore more about that specific topic, specific concept, right? This drive has more than enough resources about machine learning and also the deep learning, right? So like there is simply learn whatever content is available in our LMS that is there. Plus I have also shared you two Google Drives. One Google Drive is the day-to-day content, what we will be doing daily. And this is the another one that's my personal drive in which there is a lot of data, lot of resources available. Okay. Right, right. Starting from the core Python, the presentation is there, the core Python file is there, right? So as we proceed, I'll start addressing which code file, which folder we need to refer in order to explore more. Okay, perfect. Now, the further thing, what we need to do today is the scaling method. We have already discussed the scaling part. Yes, what exactly is the scaling? Yes, and there were three different scaling methods. Yes. So the very first scaling method is standard scaling method, right? There are possibly three types of scaling what we will be discussing. Standard scaling, min-max scaling, and robust scaling. So the very first is the standard scaler. This is the formula it will utilize in order to transform every value, and this will make the data centered to zero with the standard deviation of 1. That's mentioned as a definition of standard scaler, right? It will simply transform the data centered to 0, means the mean of the data will be 0 at the end, and the standard deviation will be more likely close to 1. So that's what standard scaler does. That's what standard scaler does. The long story short, standard scaler needs to be implemented when our data set is normally distributed. Okay. This way of scaling our data needs to be implemented when our data is normally distributed. Clear? One thing that needs to be remembered is this, that standard scaling needs to be implemented when our data is normally distributed. Second thing, in case of such algorithms like PCA and LDA, we always do standard scaling without taking care about the data distribution. So let me mention that now. If we talk about the standard scaler in normally distributed data and with the PC and LDA, we always do standard scaling. Clear? No, it is when the data is normally distributed, we go with the standard scaler. We cannot make our data standard. We cannot make our data normally distributed. If the original distribution of the data is normal, we can do the standard scaling. LDA and PCA are some library, some algorithms that most probably we'll be discussing tomorrow. They are the dimensionality reduction algorithms. So we'll be talking about these PCA and LDA in more detail tomorrow. How do we know the data is normally distributed? Anyone, guys? Anyone wants to answer? How do we know the data is normally distributed? Yes, please. Anyone wants to answer? And what are the types of charts we can refer? That's what we have discussed. Okay, understood. How do we check whether the data is normally distributed or not? Visualization won't give the exact idea. We can't catch everything through plot. We can catch the data distribution through the KD, through the histogram. We can get to know what is the data distribution. Yes. Can we understand the data distribution using histograms and KD plots? Yes. Mean, median, and mod. Okay. So again, guys, mean, median, and mod is exactly equal. That is the definition, statistical definition of normal distributed data. But if we talk about a practical data set, it's not possible to have mean, median, and mod exactly equal, right? Yes. That is one way, but that is the statistical definition, and that is something is not possible in real example. In real world data set, we cannot have mean, median, and mod exactly equal. So what is the right way to check the data distribution? Yes, guys. Yes, like if you talk about the real data, that's what we refer by saying normally distributed. Because in what I'm trying to say, in the real example, in a practical data, we cannot have mean equals to mean, median, and mod exactly equal, right? We cannot have that data. Yes. So in such type of cases, what we refer, what we do to check the data distribution? The figures, the visualizations, right? Yes. Easy. Understood, everyone? We can say that by observing the visualization, we can decide whether we need to go with the standard scaling or not. Yes, guys. We can say that we can take a good decision by observing the KD or histogram whether we need to do the standard scaling or not. Yes, only if the data distribution, if the data is normally distributed, we can go with the standard scaler. Otherwise, we have other scaling methods. Either the original distribution of the data is normal, or we are implementing PC or LDA, we need to do the standard scaling. Clear? Everyone? Perfect. Now, so right now, don't worry about these functions, guys. This is just to generate a random data set. So just don't worry about this, what exactly is these codes, functions and everything. That is just to generate some random data set for the explanation purpose. So we simply created three random normally distributed series. So if we see, we simply created X with some functions, a demo data set just for the explanation purpose. We have X1, X2 and X3. Okay. We have X1, X2 and X3. And we can see all the three series are normally distributed here, right? Yes. Okay. Now let's observe what will be the data and how the data will look like after the standard scaling. So in order to do the standard scale, we simply need to import the standard scaler. We need to create an object of standard scaler. We simply need to create an object of standard scaler, and similar to the one hot encoder or label encoder, from that object we need to invoke fit transform function. Okay, and here we have the transformed data. Now if we plot the transformed data, that's how the data looks like. Correct? Okay, now what needs to be understood here, that is the way we implement the standard scaler here. We just need to import the standard scaler class. Sure. This is just to generate a random data set. This code, cell number 229, is just to generate a random data set for the explanation. So we simply generated three random normally distributed series. Okay. Now the major things, the important thing comes from here. They start from here. We need to import the standard scaler class, right? We need to import the standard scaler class. We will create an object of standard scaler. Okay. And now this object will invoke, it will call this fit transform function that will actually transform the data into a standard scale. We just need to call this fit transform function from the standard scaler object that will actually transform this data into a standard scale. Okay, and we simply stored it in data TF. Now this is the standard scale data, right? This is the standard scale data. Okay, understood? Yes, actually, they are being transformed into a new scale, right? They are being transformed into a new scale. So the mean is different for this new scale, not the original data. This is the transform, the new scale. In 231, we are simply importing the standard scaler class from sklearn library, and we are creating an object of standard scaler class. And we will be using that object in order to invoke this fit transform function that will transform the data. Okay. We can definitely do that. We can use alias. We can also use alias. It's optional, not compulsory. It's optional. That's not compulsory. Sure. The formula is this. Every value will be subtracted with the mean and divided with the standard deviation of the data. Every value in the data will be subtracted with the mean of the data and divided with the standard deviation of the data. That's the formula to convert the data into standard scale. And that is something we can only do if the data is normally distributed. Understood the standard scaling, everyone? Everyone, is it clear? What if the data is not normally distributed? We go with the another type of scaling that is called min-max scaling. Okay. What was the purpose of this transformation? Basically, we are trying to scale the data, the series that are in different, we are trying to transform the variables that are in different scale, different ranges into a common scale. That is the purpose here. We are trying to transform the columns, the variables that are in different scales into a standard scale. The thing what we discussed yesterday about the height and the weight, right? Basically, when we implement some algorithm, when we use some any XYZ algorithm, if I talk about the linear regression, we have m and c, y equals to mx plus c, where we need to estimate the values of m and c. Now, in that case, just assume the values of x, multiple variables, are in different ranges, and the values of x, multiple variables, are in common ranges. So when we have the entire data in a standard range, in a given same range, it's quite easier to estimate the parameters, and also it's more computationally efficient. That's why we do the standardization. Scaling or standardization, all are. Standardization, standard scaling is actually the way of scaling. There are three different types of scaling. Standardization, that's called standard scaling. Min-max scaler, the another way of scaling. Robust scaler, the third way of scaling. If the data is normally distributed, we do the standard scaling. The aim of doing the scale is to put the data into a standard, a common scale, so that we have data in a given range. The entire data set should be in a given range. It will just remove that bias of having a column that has the range of hundreds, a column that is in thousands, a column that is in decimals. After doing the standard scale, every column will be in a given range, in a single given range. Yes, we talked about the example yesterday. Sure. So let's say we have 100 values. Suppose we have 100 values. Okay. So every value, it will pick, wait, let me create a sample for the data set. We have the columns x1, x2, x3, and x4. Okay. So we will be having multiple values here, right? Every value xi, every value will be applied with that formula, xi minus x bar divided by standard deviation. Every value will be applied with this formula, and whatever is the result will be placed at that value. That's how it will do the standardization. Okay. Understood the standardization, guys? Everyone? Perfect. Now, what if the data is not normally distributed? We go with the min-max scaler, and this is the formula for the min-max scaler. Okay. If the data is not normally distributed, we go with the min-max scaler. If the data is not normally distributed, we only like the standard scaling is only the case, standardization is only the case when the data is normally distributed. If the data is not normally distributed, we go with the min-max scaler. And again, I'll simply create some random data set to have skewed data set. Okay, now we can see there are three variables, there are three series x1, x2, and x3, where x3 is normal, x1 and x2 are skewed, right? Yes. Okay, now let's implement the min-max scaler. Again, the way to implement the min-max scaler is exactly same. Import the min-max scaler, create the object. Don't worry about the chi-square and the beta. That is just to generate a random series for the explanation. That is just like that function is basically used to create some random data for the explanation, right? Okay, now we simply need to import the library, we need to create an object here, right? And we need to invoke the fit transform function and specify the data set. The same pattern, same pattern. Nothing is different, just the library what we are importing is different. Okay. Now we have transformed, and let's see the data after this. Okay. Now if we observe closely what's happening after this transformation, the minimum and the maximum is actually same, right? After this transformation, the original distribution of the data is still the same. X3 is normally distributed, X1 and X2 are still skewed, but the range of the data is common now. Yes? Yes, guys? So it is actually giving whatever is required. See, the minimum and the maximum of three series are same, like instead of what we had in the beginning. The scales are different for the three series, right? They are in different scales, but now they are in the same scale. So min-max scalar is actually transforming the three variables into a common scale without losing their original distribution, right? Yes, make sense? Only mean adjusted, but the frequency range remains same. Exactly. Yes. And see, let's see what happens if we do the standard scale in this data. So if we are doing the standard scaling, we can see we are actually the data, original data distribution is also getting impacted, right? We are losing some sort of originality in the data in case of standard scaling. Yes? Yes? So that is why it's a good to follow rule to implement min-max scaling if the data is not normally distributed. But in case of PC and LDA, we'll always go with the standard scale. Okay? Perfect. Now let's move to the third type of scaling, that is the robust scaling. Now again, the robust scaling is used when the data has outliers. Okay? When the data has outliers in it. Means it will not treat the outliers, it will not take care about the outliers, it will not remove or it will not treat the outliers. It is only a scaling method if outliers are present in the data. Means at the end of the scaling, outlier will still be there. This is not the method, this is not the way to treat the outliers. In case, though this is not actually something we are going to get very frequently, because we always treat the outliers before we follow anything like scaling or anything. We treat the outliers before we do the scaling, but there could be some use cases where outliers are important, right? There are some use cases where outliers important. The one we talked about, suppose the customers that are doing expensive purchases, they are outliers, but they are prestige customers, right? They are most important customers for us. So that could be a case where outliers are important and we don't want to remove them, we want to preserve them, or like there are different ways, different possible use cases can be there. So robust scaling is again a scaling method. Robust scaling is again a scaling method only in case of outliers that are present in the data. Again, this will not treat the outliers. Outliers will still be there after doing the robust scaling. Okay, correct. It will not treat the outliers. Outliers will still be there when we, when we actually scale the data using robust scaling. There still be outliers. Got it? Now let's see. Let's observe what this robust scaling does. I simply created some again random data set, and there are two series with some outliers here, right? We can see there are outliers in both the series. Yes, guys, we can see there are outliers in both the series. right? Okay, now let's implement the robust scaler, and that's the result of robust scaler in the data having the outliers. Got it? The three scaling methods, everyone? Easy? And if I show you the coding pattern, that's exactly same. Instead of standard scalar or instead of standard scalar or min-max scalar, we just need to import robust scalar. Rest everything is exactly same. See how easy the coding is, guys. Like if we will solve 2 or 3 problem statements, like when we'll start the algorithms, you will solve 2 3 problem statements and you will be confident to solve anything then, because the coding part is very easy in Python. We don't need to write a huge lines of code or something. Once we understood the syntax, we can easily write the logics and we can easily write the instructions. When it comes to the library, what library we are using, basically most of the libraries have same programming pattern. Like we implemented 3 types of scaling, and if we know the one scaling, we can easily implement all the other 2 scalings because the pattern is exactly same. So it will take the distribution and outliers, then we will use, yes, exactly. We need to observe what is the nature of the data, and that's how we need to proceed with the scaling. And like most frequent scaling, what we do is min-max. Most frequent scaling, what we'll do is the min-max. Okay. Yes, guys. Everything is clear about the scaling. Can you give the example where we should keep the outliers? Sure. Let's suppose we have the sales data, we have customers, and what is the monetary factor, what amount of money they are spending on our business. So the people who are spending heavily are the outliers, right? Let's say there are 5% of the people, 5% customers, they are spending heavily. So they are the outliers, right? If we'll do IQR and other things, they will be outliers, right? But they are the prestige customers. They are the most important customers. Those 5% of the customers are contributing 30 to 40% of our entire revenue. So those 5% of the customers are the most important customers for us. Yes? Make sense? Is there any scaling for other famous distribution like normal distribution, gamma and exponential? Yes, actually there are, sure, there are lots of different scaling methods. There are lots of such scaling methods, and let me just share you a file in which you can explore all others. There will be a file in this drive called pre-processing methods, feature selection techniques, linear algorithms, pandas basics, preprocessing.ipynb. So you have the simply learn ML content. If you will go to this preprocessing.ipynb file, there are lots of other lots of other scaling and lots of other transformation methods explained in this file. Let me just walk you through. Data wrangling, visualization, model training. Okay. Transformers, estimators, min-max, robust, normalizer. Robust was 4th, third was min-max, second was standard scalar. Okay, first was the pre-processing. Then binarization, imputation, polynomial features, custom transformer, text processing. So this has everything. You can explore this file. Okay. Perfect. Yes, guys. All good with these transformation techniques. Everyone. Awesome. Okay. Now the last thing to discuss, that is the steps to follow the machine learning. The very first step is to understand the problem statement, right? Right? The very first thing is to understand what exactly is the problem. Does this problem actually requires any machine learning algorithm or not? I see this is a very huge mistake. Lots of beginners do. Instead of understanding the problem statement and thinking of the possible scenarios to solve the problem, we directly jump to the algorithm on a given data set, right? So that's not all the time what we need to do. We need to understand the problem, we need to understand the data, then only we need to decide whether then it will require some algorithm or not. Exactly, definitely, guys. There are lots of such cases, like during the interviews, if I give some scenario, some use case to a person, that this is the use case, how will you solve it? The people, like, they directly jump to the algorithm. We'll use this algorithm. This is supervised. We'll go with this algorithm. But actually, that business problem, that data set will not require any algorithm at all. You can simply solve it using dashboards. You can simply solve it using some basic analytics. So that's the first thing what we need to do before we solve any machine learning problem. Understand the data, understand the problem statement, think whether it is necessary to use some machine learning algorithm or not, or we can directly achieve the task. Yes, yes. Understanding the problem statement. Second is to understand the data. That's called EDA. Understand the data. That's called EDA, exploratory data analytics, right? Exploratory data analytics. Analytics. So now, what is this understanding the data? Sometimes we can understand the data from the we can understand the data from the business perspective sometimes, but that's not always the case. We cannot have the business knowledge about every problem, right? Sometimes we can definitely explore what column what column explains what term in that industry. Sometimes we can have that information. Sometimes the data is completely encoded, so in that case we just need to interpret it on the basis of statistics, right? On the basis of statistics. So that's what the second step is. Understand the data with respect to the domain if possible. Otherwise, understand its statistics, their distribution, what is the correlation, what is the relationship, how the data is going to be helpful, what is going to be helpful and all. So just try to understand, explore the data set. That's the second step. Easy? Understood? Third is data pre-processing. Right? Third is data pre-processing. What happens in data pre-processing? We basically take care about the outliers, missing values, and duplicates, what we discussed, right? Missing values, outliers, duplicates. Then apart from that, we also need to check scaling if required, right? And there is one more thing called class balancing. Have we talked about the class balancing, guys? Now this is only if required. It's not it's not something we need to do every time. It's only when it's required. Class balancing, let me give you a small example. Suppose we want to detect whether a given patient is having some disease or not. For example, we want to build an algorithm, we want to build a model that can predict whether a given patient has some disease or not, right? And let's suppose the data set what we have, in that data set we only have the data for 100 patients, And out of those 100 patients, only 7 patients have some disease and 97 patients are healthy. And that's actually the case. That is usually the case. We don't get a lot of diseased people. So we are working on a specific disease, and we want to build a model that can detect that disease. And what data we have right now to utilize, out of 100 patients, only 7 patients have disease and 93 patients are healthy. That's a possibility, right? Now, if our model, if our algorithm is predicting everyone healthy, it will be still 93% accurate, right? If the model is saying everyone is healthy, still the model is 93% accurate. But that's of no use, right? That 93% accuracy is of no use. Yes, guys? So that's called imbalanced class problem, and in such case we need to deal with the imbalanced class problem and we balance the class. How do we do it? We'll discuss it more detail. Understood? Point 2 again, outliers. Point 2 is the outliers. EDA is all about the exploratory data analytics, in which we try to understand the data. If possible, we can understand it with respect to the domain or the industry, or else we try to understand it with respect to the statistics, like what are the correlation distributions and all those things. Fourth is feature engineering. Okay. Now in feature engineering, what we actually do, we try to extract the important information out of a given huge amount of data. Let's suppose in a given problem statement, we have 100 columns. Now, not all the 100 columns are going to be helpful, right? So we need to select the most important out of those 100. Yes, guys? Make sense? Right? And the way, the method or the steps to select or drop the good columns or irrelevant columns is feature engineering. Feature engineering also covers generating new columns if the number of columns are not sufficient. So feature engineering is all about playing with the columns, selecting the important one, dropping the irrelevant ones, or also generating the new columns in case the number of columns are not efficient. They are not sufficient, right? Got the idea what exactly is feature engineering? Sure. Suppose we are trying to predict the sales. Okay. Now, when we try to predict the sales, the contact number of the customer is not going to help us in predict the sales at all, right? So that's not important. We need to drop that column. Yes. Advertisement amount, the most important column. So this kind of thing, this kind of analysis, which is important, what needs to be utilized, what should be dropped, that's something we do in feature engineering. Okay, now in feature engineering, basically there are two factors what we need to take care about, and again we have algorithms that will give us the relevant result based on those two factors. What are those two factors? One is called multicollinearity and one is called significancy. One is called multicollinearity and one is called significancy. So these are basically the two factors what we need to take care while doing the feature engineering. Okay, now what exactly are these two factors? Let's understand one by one. Multicollinearity means the relationship between the columns itself, right? The relationship between the column itself. Let's pick some practical example. Suppose we want to select a cricket team. Let's take an example. We want to select a cricket team, the playing 11. Okay. So what will be the approach? The playing 11, the 11 players we will select, they are going to have different skills, different properties, right? We will try to pick unique players. We won't select three players with exactly same skills, like all the three players are having the same form of batting, or all the three players are having the same form of bowling. We try to keep the players, we will try to select the players with different skills and different properties, right? Yes, make sense? We will not select the player, we will not select the player that are very similar to each other, so that we can give the variety of, challenges. So that's how we are going to select a cricket match, and that's what the cricket team, and that's what we try to apply while we select columns for the modeling. We will try to avoid the similar columns, right? If there are three columns that are actually explaining the same sort of information, we only select one out of them. Let's say there is a date column that is telling the date of sales, there is a column that is telling the day of sales, there is a column that is telling the month of sales, there is a column that is telling the business quarter of the sales. So all these four columns are telling the time factor only, right? So they, all the four columns will be explaining the similar thing in the data. Yes, they are going to explain the similar information. So we need to drop such columns that are very highly multicollinear. We need to pick the columns that are independent to each other. Make sense? That's what the multicollinearity is. Multicollinearity means selecting independent columns. If the column is very similar, very multicollinear, we should not select that. Again, there are, there are exceptions in all those things, but the idea behind the multicollinearity is we should select the independent columns for our modeling. Heat map is, yes, a possible way to do this, but again, there are more effective methods to implement this. Okay. Is there a function? Yes, definitely there is a function. There are algorithms that can give these things. We'll talk about that in more detail. Just let me know if this, what exactly is the multicollinearity is clear. The data should be independent to each other. It should not be very much related. We want data to be independent to each other, right? Right? Yes, multicollinearity makes sense, everyone? Okay. Now, multicollinearity means we should select the players with the different skills. Does not mean that we will select someone with, we will select some basketball player, right? If we are trying to select the players with different skill set, this does not mean that we will select some basketball player, because he is going to have completely different skills. We are not going to select a basketball player. We need some players that can, we need such players that can help us to win a cricket match. That's called significancy. So along with the multicollinearity, we need to take care about the significancy also, the relevant ones. Yes, the relevant ones. So the columns should not be independent to each other, but it should be dependent to the target, what we need to achieve, that is the sales. Yes, the same example, contact number is going to be completely different, but it's not significant. Contact number cannot help us to predict the sales. So we should not use the contact number, even if it is very less multicollinear. Make sense? Multicollinearity and significancy, guys? Sure. Multicollinearity is clear? Perfect. Significancy is simply having such variables or such columns that are significant to our end objective. We want to select a cricket team, so we should be selecting the players that can win a cricket match, not the player, like, the, as per the multicollinearity, we should have the players with different skill sets, right? So that this does not mean that we should select a basketball player, though this, that player is going to have a completely different skill set, but that's not significant for us. That's called significancy. Means the basketball player cannot help us to win a cricket match. Make sense? Multicollinearity means the variable should not be multicollinear. It should not be related to each other. The factors what we will be using for our modeling should be independent to each other. Significancy means they should be independent plus significant means they should be dependent to the target. They should be independent to each other but dependent to the target. That's what the overall feature engineering is. Definitely, both are important. Both are important. And the algorithm what we use in this case, the algorithm what we will be discussing are principal component analysis, principal component analysis, and linear discriminant analysis. Called PCA and LDA. So these are the algorithms that we use in feature engineering. Clear, guys? Clear about the feature engineering? Awesome. Now after the feature engineering, what we do is called train test split. Fifth step is called train test split. Now again, I'll give example to understand what is train test split. Now what is this train test split? Suppose I have a student. I want to train that student for exam. Okay. Now I have 100 questions with their answers. Okay, and that is the only data what I can use to train that student. Take this example, take this scenario. I have a student. I want to train that student for a given exam, and the data I have to train that student is 100 questions and 100 answers. The one use case, I gave that student all the 100 questions and answers to learn how to answer the questions, right? I gave that student all the 100 questions along with the answers to learn how to answer the questions. Make sense? Yes? Possible? I gave that student all the 100 questions along with their answers to learn how to answer the questions. Okay, now once he will say that yes, I'm perfect, I have learned everything, I will only give him the 100 questions or only 10-20 questions out of those 100 questions, and he will give me the answers. I will compare those answers with the actual answers to evaluate how better the student has learned, right? Possible? This one way of making him learn, training that student. Possible? Right? Okay. Another way. Okay, now in this case, what's happening? The evaluation phase, when I'm only giving him the questions, those questions are already seen, means that student has already gone through with those questions. During the evaluation, what 20 questions I have given, that student has already gone through with those questions, right? That is that data is something already like student is already aware of. Now let's understand the second use case. Out of those 100 questions, I only gave him 80 questions to learn, questions and answers, right? I only gave him 80 questions along with the answers to learn. Once that student will say, okay, I'm learned, I'm confident, I will give remaining 20 questions only, not the answers, only 20 questions, and he will give me the answers. And I will evaluate how accurate the answers are. So which one is the better way, guys? The first or the second? Second, right? Right? This is what the train test split is. We have the entire data. We don't give the entire data for training. We split the data. We preserve some data for testing, and we give the data for test, like we use the test data for the evaluation. Make sense? Oh, this is in this corner. Ratio is subjective. Sometimes we use 70-30, sometimes we use 60-40, depends upon the data and the complexity of the problem. How exactly this goes? How exactly this goes? We have the data, okay, that includes, before this, excuse me, before this, let me draw. Okay. Suppose this is the X and this is Y, what we will be predicting. And let's say we splitted this data with 70% and 30%, right? Now this is train X, this is train Y. This is test X, and this is test Y. Okay. Now we will give data to the machine learning model for training, right? Basically the training data. And that is the train X and train Y. Train X and train Y. We gave it to machine, right? And machine will generate a learned model. That's a learned model. Now we will give only test X. This will make the predictions, right? And we will compare those predictions with test Y to calculate its accuracy, right? Make sense? Easy? Yes, that's how we train a machine. That's how we train a machine. Awesome. Okay, can you please try to let me know where exactly you have confusion? After the split. Okay. So what we did, we gave the training data to the machine learning. Means we gave those 80 questions along with the answers to the student in order to learn. Once the student is learned, we are only giving the test data. That is something student haven't seen. The remaining 20 questions what I preserved, right? So after the student is learned, I gave those 20 questions. The student will give me the answers. I'll compare those answers with the actual answers what I already have, and I will evaluate how confident the student is, right? Correct. Okay, now the evaluation is again different, guys. If it is a classification problem, means we are trying to evaluate something categorical, so in that case either the prediction will be correct or incorrect. Yes, in case of predicting category, the evaluation will go like this: if it is either it is correct or it's incorrect. Yes, that's how the evaluation will happen. But in case of regression, means when we are trying to predict something continuous, let's say sales or something, it won't be like correct or incorrect. It will be how close we are with the actual value. Yes, like objective questions. Objective questions will be like correct or incorrect. Either you are correct or you are incorrect. That's what happens in objective questions. But in subjective questions, how close you are to the actual point. Similarly, the classification and regression. In case of classification, either the prediction will be accurate or incorrect. If it will be correct or it will be incorrect. That's how each and every prediction will be evaluated. But in case of regression, in case of predicting something continuous, we will see how close we are to the actual value. Make sense? So again, evaluation, how do we calculate this accuracy, has different methods. How do we calculate this accuracy has different methods, and that's something we'll discuss later on. Perfect. So that's all about the basics. That's how we solve a machine learning problem. Understood, everyone? Awesome, guys. Sure, I'll upload the how we will know it is the closest. We will have the actual value also, right? Suppose the actual sales are $150,000. So what are the predictions? We can see whether they are close or not. Today is day 4, right? Okay. Now just let me know what all needs to be uploaded in day 4, guys. Yes, thank you so much. Thanks for reminding the things. Let me just create a day 4 and let me upload everything. Okay, first of all, sure. First of all, okay, let me just upload it from here. So PyPlot is to explore the visualizations, right? We have finished the pandas also. So let me upload a project also. Try to explore this data sets and the questions mentioned in the project. This requires a correction if I have already done. Yes, only 3 data sets. Okay. So I have also uploaded the pandas project to explore. I have uploaded this PyPlot file. To understand more about the pandas, I will also upload one pandas file. Here it is. This is to go through with complete pandas from basics till advanced. Let me also upload the pandas basics, what we did today. Okay. What else was required, guys? I have uploaded the visualization, today's file, other pandas references, projects also. What else? Okay, yes. Yes. Ebook. I actually don't have the ebook. I'll share you the link. How we can check the IPY files, guys? This is the fourth class, and that's what we discussed in the very first class. How to download and open a notebook file. Yeah, just open the Jupyter notebook in your system, upload the files, or you can just go to the downloads and open them from there. Okay, I have updated the visualization things. Anything else is required, guys? Ebook, yes. There is one from O'Reilly. Yes, you can refer to this ebook. Here we go. Refer to this ebook. I think that's it. Cheat sheet which can be referred to check which function needs to be used. Uh, I will upload, there are some things like I have updated few of them in my Instagram. I'll just copy from there and I'll upload it in the drive. Pre-processing. Okay, wait, just a sec. I think pre-processing is there. P. I don't see. You can download it from here, from other other drive link. My LinkedIn. I actually shared that link. Let me share it again. No, that's it. That's everything. We are done for the today's agenda, guys. That visualization I just shared in order to, if someone wants to explore, if someone wants to explore more about the visualization, I have shared that file, so you can definitely, refer and explore. If you want to look at EDA, let me just navigate you where you will get the EDA. Pre-processing is available in the drive link what I have shared right now. You can just scroll it down. The preprocessing.ipynb is available here itself. Here it is. Okay. Yes. So you can just download it from here. What else? Okay, let me just navigate you for the EDA. Linear algos, Bigmart sales. What is the file name? Get info. Okay, so you can refer to this one. You can, I think one of them is having the EDA. Actually, like one is having the predictions. Like there are two files, two IPYMD files. One file is complete till model building and predictions, and one file is only having the EDA. The EDA is there in both. Okay, so you can refer to any file if you want to learn more about the EDA. Okay. Yes, guys, we are done for the day. We can definitely drop off. We are done for the day. We can definitely drop off, guys. If anyone have anything, please. Otherwise, we are good. We should start with to build. For the data sets, guys, I have uploaded Pandas projects, practical Pandas projects. So you can definitely refer to the Pandas practical projects. Okay. In order to practice the Pandas codes and other things. Okay. LinkedIn, sure. That's my LinkedIn, guys. Yeah. I actually haven't downloaded that ebook yet. I've shared you the official link from where you can, get it from like O'Reilly websites itself, but I haven't downloaded it yet. You can actually not given specific time. You can just drop your comments or whatever is there. I whenever I'll get chance, I'll look at it. Okay, whenever I'll get chance, I'll definitely look at it. Perfect. Received a lot of guys. If I'm unable to, if I'm unable to accept the request, you can definitely give a follow because I think my connections are like they have reached the limit. Perfect. Yeah, we will talk about that also at the end of the session. We are going with a good pace. We will get some ideal times. We'll talk about that as well. No, we will discuss in the session itself. We will discuss in the session itself. I can't teach personally. So I'm not sure how it can be done, but let's say you can like if I have any further batch aligned for deep learning and further things, I'll let you know. Perfect. That's everything, guys. Thank you, everyone. Thank you all. See you tomorrow. And please try to do some revision, some practice. Refer to the self-learning videos about the pre-processing. Okay, that's there in chapter 5, I think. In self-learning, there is chapter 5 that is feature engineering. So that's what we will be doing tomorrow. If you can go through with these videos, that will be really helpful. Perfect. Thank you, guys. Thank you, everyone. See you tomorrow. Bye bye. Take care. And make sure you spend you spend 5 minutes for the feedback thing. We have already shared you the link, and once you drop off the session, a link will be it will be populated, and you just need to give the feedback. We consider 9 or 10 as a good. Anything below 9 is something consider like something concern for us. So just do mention what went wrong and where we can improvise. Perfect. Thank you, guys. Thank you, everyone. Bye bye.
Thank you, sir. Thank you for the wonderful session and thank you everyone for your participation. I request everyone to kindly fill the feedback survey form. We have shared the link in the chat box. Please do share your comments.
Yeah. Thank you, guys. I'm dropping off. Thank you, everyone.